let's look at how we can use trig identities as a way of simplifying, rewriting, and overall just making our lives a little bit easier as we get something that's a little more workable than a weird, funky equation. So to start, let's go through some of our trig identities, the ones that we're going to use pretty frequently. The first set of trig identities that we're going to be using a lot are the reciprocal identities. These are probably the ones we use the most overall, and based on that name, reciprocal, it's going to have to do with flipping a fraction. So if I have 1 over sine of x, that's the reciprocal of sine is going to be cosecant of x. And then on the flip side, 1 over cosecant of x is going to equal sine of x. We also have 1 over cosine of x, which is going to equal the secant of x. And on the flip side with that one, 1 over secant x equals cosine of x. And our last example is going to have to do with our last main function, 1 over tangent of x equals cotangent of x. And flipping that over, 1 over cotangent of x equals tangent of x. So these are our reciprocal identities. Related to the reciprocal identities are our quotient identities. When we're talking about quotient identities, there's only 2 of them, and it's the 2 trig functions that are ratios of other trig functions. The first one is going to be tangent. This is the one we're going to, of the 2, this is the one we'll probably use the most often. And we have that tangent of x equals sine of x over cosine of x. We also, thinking about our reciprocal identity, cotangent is the reciprocal of tangent. So that is going to imply that it's going to be the reciprocal of sine over cosine. So we flip that fraction over. Cosine of x over sine of x. Our next big set of trig identities is our co-angle identities. When we're talking about co-angles, it's basically shifting over by pi over 2 and reflecting. So we're going to have one for each of our trig functions here. And we're going to have that sine of x equals cosine of pi over 2 minus x. And cosine of x is going to equal the opposite. Sine of x, or sine of pi over 2 minus x. It's this same pattern for all groups of these. So we also have cotangent of x equals tangent of pi over 2x minus x. And tangent of x equals cotangent of pi over 2 minus x. Essentially, these are all the same exact pattern. It's just that pi over 2 minus x, pi over 2 minus x. And they're going to relate to each other really nicely that way. So our last option here is going to be secant and cosecant. And we're going to have that secant of x equals cosecant of pi over 2 minus x. And that cosecant equals the opposite, secant of pi over 2 minus x. So those are our co-angle identities. These are a way, if you have stuff stuck inside your parentheses, it could potentially save us one of our rules so we don't even have to use it. It's a rule coming up, but it could save us a lot of steps. ones that are used pretty frequently, but are honestly some of the harder ones to see, just to be aware. With these ones, when we're looking for these, we're always going to be looking for squareds. Because think Pythagorean theorem, if we reflect back on that from when we learned it before, that's a squared plus b squared equals c squared. Same situation going on here, except instead of a, b, and c, it's sine values, cosine values, secant values, tangent values. It's all of our trig values. So to start, our most basic version, and the one we probably use more than any other, is sine squared of x plus cosine squared x equals 1. Quick note, in case you forgot or you don't remember, or you've never seen, if we have cosine of x squared, we can also write that as cosine squared of x. We do that so that it doesn't look like the squared is attached to the x. We know that it's attached to cosine. So this is sine of x times sine of x, not sine of x times x. Now, our next one is going to involve tangents, and that's going to be tangent squared of x plus 1 equals secant squared x. And our very last one, 1 plus cotangent squared x equals cosecant squared x. Now, all of these can be moved around, shifted around, adjusted. That's something that's done all the time. So you could have 1 minus cosine squared, and you could replace that with sine squared. So any of these can be rearranged and adjusted to fit the needs of your problem. Another one that we use really frequently is even and odd identities. When we're talking about even and odd identities, we need to think about what even and odd mean. Even means that it's something that is symmetric across the y-axis. There are only 2 functions that are even, and the 2 functions we have that are even are going to be cosine x. So if we plug in negative x into cosine, we should get out the same value as if we had plugged in cosine of x. So it's a way to get rid of that negative sign. Same thing with secant, because secant is just 1 over cosine, so the same rules apply. Secant of negative x equals secant of x. We also have our odd functions, which is everything else. So sine of negative x equals negative sine of x. Cosecant of negative x equals negative cosecant of x. Same with tangents. And cotangents. And you could verify all of those based on all of the other identities, as long as you remember this one and this one. Now, with many of these identities, you don't need to memorize all of them. Just having a couple of them, one from each pattern, will help you kind of rediscover each of them if you need. But I would encourage you, have some of them that you know down pat, the ones that are really common, and find a cheat sheet, something that you can print out or write a copy of, have it somewhere in your notebook, maybe in the very front or the very back of your composition book, somewhere where it's easy to find, because these are going to be really. All right, so here's an example that we want to simplify as much as possible. One tip that I have for you, this is how I usually look at these. First thing I generally want to do is I want to convert everything into sines and cosines, because if everything's sines and cosines, then I might be able to cancel some stuff out. So I'm going to start by simplifying that tangent. And for this one, that tangent is going to become sine of x over cosine of x times, now cosine of x is just cosine of x. Now, when I'm multiplying these through, cosine of x is the same as cosine of x over 1. I am not going to cross cancel. That's something that a lot of times tends to lead to some errors. So I tend to stay away from it just to make sure that I'm not making any mistakes as I'm canceling things out. So I'm going to rewrite this, multiplying everything through. That's going to end up giving me sine of x times cosine of x all over cosine of x. Now I have a cosine on top and a cosine on bottom, so those are going to cancel each other out. And what we end up coming away with, tangent of x times cosine of x is going to equal just sine of x. Quite a bit simpler. If we were trying to take the derivative, I would much rather take the derivative of sine of x than have to do the product rule. Here's an example. I want you guys to try this one on your own. First off, convert to sines and cosines, and then I think that we have something that we can distribute before we get rolling. So pause the video, try that out, see if you get the answer, and we'll come back and solve this one in just a moment.